Hello all. Our today's topic for discussion is frequent pattern growth algorithm, that is FP growth algorithm. So prerequisite is a priori algorithm. There are two primary drawbacks of a priori algorithm. First one is at each step candidate sets have to be built, and second is to build the candidate set the algorithm has repeatedly scanned database. So these two properties make the algorithm slower. To overcome these redundant steps, new association rule mining algorithm was developed named as a frequent pattern growth algorithm. It overcomes the disadvantages of a priori algorithm by storing all transactions in tier data structure. So that FP growth algorithm, how it works, we will check. So to overcome this redundant step, the new association rule mining algorithm was developed named as frequent pattern growth algorithm. This algorithm is an improvement to a priori method, that is a priori algorithm. A frequent pattern is generated without the need for candidate generation. So candidate generation is not required, and FP growth algorithm represent the database in the form of tree called as frequent pattern tree or FP tree. So what that FP tree is, that is frequent pattern tree is like it is tree-like structure that is made with initial atom set of the database. The purpose of FP tree is to mine the most frequent pattern. Each node of FP tree represent an atom of atom sets. Okay, and root node represent null. So at the starting, for building tree, whatever root node is, which will be represented as a null, while the lower nodes represent atom set. The association of the nodes with the lower nodes, that is atom sets, with the other atom sets are maintained while forming the tree. So that is tree-like structure is going to form, and root will be represented as a null. Okay, so we will check FP growth algorithm with example. So like a priori algorithm we discussed with example, same way we will discuss FP growth algorithm with example so that it will be for better understanding. So whatever data set or data is given, you can check here transaction ID and items. So T1 to T5, these are transaction IDs, T1, T2, T3, T4 and T5. And atoms, those are represented in next column. So whatever data is shown here, or data set is shown here, that is hypothetical data. That is each letter representing an atom. For example, E, K, M, N, O, Y for transaction ID T1. So whatever letters are there, those are nothing but atoms. And the frequency of each individual atom is computed. Next table which is shown, that is frequency of each atom which is available in that data set is computed. Same as in same first step we followed in a priori algorithm. For example, if you will check here A alphabet, that is we can consider it as A atom. So A atom, how many times it appear in this transaction or in this database, that is nothing but you can observe here only in transaction T3 A is appeared. So frequency is 1. Same way you can calculate frequency, or in this table frequency is given for all atoms which are there in this data set or database, we can say. For example, if you will check for C, how many times it appeared in this transaction? It is there directly for T4 and T5. So twice it is there. So frequency of that atom is 2. Same way, it is calculated for all atoms which are there in this data set or in this database. So first step, similar to a priori algorithm, that is nothing but checking or frequency of each atom is computed. Okay. Uh, if we will consider here that is nothing but minimum support, which we already discussed in our prior algorithm. If we will consider minimum support 3, that is nothing but at least thrice in database if that atom is present in transaction, in all those transactions, at least thrice if that atom is present, then we will consider that atom. So here you can consider for this example, that is, let the minimum supported be 3. A frequent pattern set is built which will contain all the elements whose frequency is greater than or equal to minimum support. And these elements are stored in descending order. Here we can check the minimum support 3. A frequent pattern is set is built which will contain all elements whose frequency is greater than or equal to minimum support. These elements are stored in descending order of their respective frequency. After insertion of relevant atoms, the set L looks like this. That is nothing but, if we will check previous table, that is nothing but we have checked here frequency for each atom, and here we will consider only atoms whose frequency is greater than 3. So which are those atoms? That is K5, E4, M3, O3, Y3. You can check here also K, M, O, Y, E having greater than 3. That is nothing but minimum support greater than 3. These elements are stored in descending order of their respective frequency. After insertion of relevant atoms, the set L looks like this. So just now whatever we discussed, that is set L will look like this. Now for each transaction, the respective order atom set is built. It is done by iterating the frequent pattern set and checking if current atom is contained in the transaction in question. If the current atom is contained, the atom is inserted in the order atom set for the current transaction. Check here. This step is important. That is nothing but, and this is different from a priori algorithm. Whatever first two steps we discussed, those were same for a priori algorithm. Now from this step, changes are started. For example, P1. Which atoms are there? That is nothing but E, K, M, N, O, Y. Now in order atom set, what is considered and how it is considered? That is important. So whatever list L is built, in that list, whatever atoms are available, those are considered in order atom set. For example, transaction P1, these atoms are there. From these atoms, only atoms which are considered in order atom set, that is nothing but which are or which are giving minimum support criteria 3 or above 3. So those are considered here. So already we discussed K is there, E is there, M is there, O is there, and Y is there. K, E, M, O, Y. So in transaction P1, K, E, M, O, Y. One more point here, that is order will be considered or order will be written in same manner which we have taken for list L. So same order will be considered. Same way if you will check for T2, these are the atoms, but from these atoms, which atoms will be considered? That is nothing but from L list, or in this L list, what are atoms are available. So which atoms are available for T2? That is nothing but K, E, O, Y. So these atoms will be considered. Same way you can check for other transaction, that is from T1 to T5, whatever atoms are available, order atom set is built depend on whatever list is formed here. Okay, this step is important, and order atom set, that table will be added with one more column with order atom set. So that you need to check. So this is first step, or we can say this is third step, but it is different from a priori algorithm. So you need to check those things. how it is done or how this table is built. Now check this step. Now all order atoms sets are inserted in triad data structure. Now main thing or from this step, here we are going to start with building FP tree, we can say. So as we discussed at the starting, root node will be null. Okay. Now starting with first step, that is nothing but T1. For T1 transaction, we are starting with T1. So transaction T1. So KEMOY, K equal to 1, E equal to 1, M equal to 1, O equal to 1, and Y equal to 1. This is first step. Or for first transaction only, we started with FP tree. So here all atoms are simply linked one after other in order of occurrence in the set and initialize the support count for each atom as a 1. That is first step. Now we will build or in same we are going to add next transaction T2. So check for that. Now which atoms need to be inserted here? That is K, E, O, Y. So inserting the set K, E, O, Y, that is for T2. Now what is done or how it is inserted? That is till the insertion of element K and E, simply support count is increased by 2. Sorry, increased by 1. That is prior to this it was 1. Now you can check here. It was 1. Now for this step K equal to 2, E equal to 2. Now next is O. But in this sequence next is M. So what is done? K, E, O. Now O is inserted having count 1. Next is Y, which is inserted having count 1. Okay. So for transaction T2, it is built like this. So on inserting O, we can see that there is no direct link between E and O. So therefore, what is done? That is therefore separately O and uh, atom set O or atom O and Y are inserted. So new node for atom O is initialized with support count as 1 and atom E is linked to this new node. Okay. On inserting Y, we first initialize new node for the atom Y with support count 1 and link the new node of O with the new node of Y. So this is for transaction T2. Now check for transaction T3. Similar manner we are going to build that FP tree for each transaction. So check next, that is for transaction T3 which elements we need to insert, that is KEM. So how it will be? So already KEM are in sequence. So what is done? K value is incremented by 1, E value is incremented by 1, M value is incremented by 1. Because they are already in sequence, only count is increment or count is increased by 1. Here simply the support count of each element is increased by 1. Okay. Now we will go for T4. So check for this. That is nothing but we are going for T4. So T4, which element we need to insert? K, M, Y. So K is present, we will increment it by 1, it will become 4. But in sequence, M is not there. So similar to previous step, that is first support count of K is increased, then new node for M and Y are initialized and linked accordingly. So after K, M is inserted, okay, having support count 1. Now Y is inserted having support count as 1. So this is for T4 step. Now we will go for next, that is T5. So which elements are there in order atom set, that is K, E, O. So now we will again check K is present, increment it by 1. Now next is E, increment E count by 1. You can check previous values. Those were 4 and 3. Now they are becoming 5 and 4. Now last element, that is nothing but O. So link is available between for K after E and then O. But for O count is 1. It is going to increment here, that is by 1 it is going to increment. So it will become 2. So value for O or support count for O will be 2 here. Okay. So here simply the support count of respective elements are increased. Note that the support count of new node of atom O is increased, is also increased. That is nothing but prior to this it was 1 and now it is for O support count is 2. Now for each atom the conditional pattern base is computed. Prior to next step, this is nothing but FP tree which is built for this transactional database. So if you will check this database and we have formed order item set, and using this order item set we have built FP growth tree or FP tree we can say. So this is final step and this is nothing but tree is built. Next step is also there, or next step is given which we will check. Now for each atom the conditional pattern base is computed, which is the path labels of all paths which lead to any node of the given atom in frequent pattern tree. So note that atoms in the below table or atoms which is given in that table are arranged in ascending order of their frequency. So if you will check tree which is built, now check Y O M, for Y O M E K. If you will check K E M O ascending order. So K E M O 1. Now same if you will check for Y O M. So KEO, that is also there. That is nothing but same way whatever we discussed. So that is conditional pattern base. So accordingly conditional pattern base is built. That is depend on which atoms are there or which links are there. In detail steps are given here. One more point, I am not going to read these steps. Whatever example we discuss, directly we solve that example. So you can go through these steps if you want to solve next example. At that time you can check these steps. But what basic thing, that is for building FP tree or for FP growth algorithm, different ways are there to build FP tree. So one way I discussed key in this manner FP tree can be built. Somewhere if you will check some complex things are given, instead of that go for simple things and build tree accordingly. If you want other steps or other method also you can follow for building FP tree. One more point, that is you can watch this video which I have mentioned, YouTube link I have shared here. So you can go through this. Here also for building FP tree, how it can be built in simple manner and easy way it is given. This method is somewhat different, but final FP tree will be built in same manner which we discuss in our example. Same way FP tree is built. So this is last point or this is related to FP growth or FP pattern growth algorithm. With example we discuss, so you can try for other examples. In a question paper or in university question paper also for FP growth algorithm, questions or examples are asked. Watch this video for more details or some other examples if you, or other method if you want to check for FP growth tree, you can check that.